the algebra review, and some of you might show a lot more work than this, but I do think eventually you need to make it to the point where you do not need to write down what you're going to do to both sides of the equation. Like if you look at this first one, we have x plus 7 equals to 10. I know I want to get x by itself. I've got to get rid of the plus 7. We know that addition and subtraction are inverse functions of each other. So if I want to move the plus 7 from the left side of the equation and I want to move to the right side, I have to subtract 7 from both sides. Now I know some of you are going to put like minus 7 on the left side and minus 7 on the right side, and you're going to put a bar and then you're going to do the operation. I think we have to move to the point where we are mentally doing some math in our heads. Now, I do think we should be able to say, hey, what are we actually doing to both sides? Well, right there, I said it. I subtracted 7 from both sides. Subtracting 7 from the left side gets rid of the plus 7, and 10 minus 7 is 3, and we're done. Let's look at number 2. Number 2 says 20 equals 4x. And when you see 4x, that's 4 times x. Well, we know that the inverse operation of multiplication is division. So how do you want to get the x by itself? I want to divide by 4. So I divided both sides of the equation by 4. That will move the 4 from the right side. It'll move it to the left side, because dividing both sides by 4 the 4 divided by 4 is just 1, and then 20 divided by 4 is 5. And again, I'm not going to show that step. That is the step. I'm going to identify what I'm going to do, but I am just going to do that, and I'm always going to do it to both sides of the equation. That's the whole point of the algebraic property of addition, subtraction, division, and multiplication. I do things to both sides. I'm never just going to do it to one side. Okay, look down here. This is x divided by 5 equals 3, or x over 5 equals 3. I want to get rid of the 5. The 5 is dividing. So of course, to move it to the other side of the equation, I have to multiply. So what did I do? I multiplied both sides by 5. 3 times 5 is 15, and then I'm done, right? I'm still telling you, and I kind of wrote this step. This right here is written in the middle of the start and the end. This is telling you what I did to go from here to here. To go from here to here, I subtracted 7. To go from here to here, I divided by 4. And again, I'm always doing it to both sides of the equation, right? 18 equals x minus 7. What do I do to both sides? Well, I'm going to add 7 to both sides. I want to get x by itself, and this is a minus 7. I want to add 7. That will move the minus 7 to the left side of the equation and make it 25, right? 18 plus 7. Now I have two-step equations, right? I have to work backwards. I got to get rid of the minus 5 first. So to go from the first line to the second line, I'm going to add 5 to both sides. Again, always to both sides of the equation. So when I add 5, the 2x is just going to sit there for a second. I'm going to add 5. 13 plus 5 is 18. And now I have this equation. How do I go from here to the last line? Well, I have 2 times x. Well, that means I need to divide both sides by 2. 18 divided by 2 is 9. One step to the next step to the next step. The red is telling you what I did to both sides of the equation to go from the first to the middle, and then from the middle to the end. Look at 6. Okay, I have negative 8 minus x equals negative 10. And there are a couple of things I could do here. The first step is I actually could have got rid of all the negative signs. I could have said 8 plus x equals 10. And how did I do that? I could have multiplied everything by negative 1. But I chose to do it this way. I got rid of the negative 8 by adding 8 to both sides. If I add 8 to both sides, I'm left with negative x equals negative 2. And since they're both negative, I can either multiply or divide by negative 1. And you get a negative divided by a negative, which is a positive, and a negative divided by a negative, which is a positive. Either way, I get x equals 2. Look at number 7. I'm going to subtract 5 first. 17 minus 5 is 12, and that's going to leave on this side of the equation the negative 3x, and negative 3x is negative 3 times x, so then I'm going to divide by negative 3. 12 divided by negative 3 is negative 4. Again, these are all two-steppers. What did I do? And then what did I do? Same thing here. I'm going to add 11 first. 4 plus 11 is 15. And then I'm going to multiply by 2. 15 times 2 is 30. Again, I'm going to get rid of subtraction with addition. I'm going to get rid of division by multiplication. Just like over here. Subtraction, addition, multiplication, division. Those are inverse operations of each other. Okay, we get a little more complicated over here. These are kind of like, this one's a three-stepper. The first thing I'm going to do, this 1/3 out in front, that's the same thing as just dividing by 3. So I'm going to multiply both sides by 3. And I get this line. Then I'm going to subtract 5 to get rid of the 5. Adding 5, subtract 5. Multiplying by 2, divide by 2. So boom, 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 boom. Multiply by 3, subtract 5, divide by 2. Why did I do those things? Because those are the inverse. The inverse of division right here. Oh, I can't highlight that very well. The inverse of division is multiplication. The inverse of addition is subtraction. The inverse of multiplication is division. You're undoing, you're unraveling the big equation to get to this final little step here, right? That's the whole goal. Find x. If you look at number 10, the first thing I'm going to do is multiply by 4, because right in here I have this divide by 4. Then I'm going to subtract 5 to get rid of adding 5. And then I'm done. 2-step. Right? 11 is a 4-step equation. I'm going to get rid of the plus 7 first by subtracting 7. Then I'm going to get rid of dividing by 2 by multiplying by 2. Then I'm going to get rid of the minus 6 by adding 6 to both sides. 3x is 3 times x, so then I'm going to divide both sides by 3. I'm always doing it to both sides of the equation. Now, can you show all your work? I think it just honestly gets messy and confuses you guys. I would suggest doing what I am doing and doing things to both sides of the equation and just slowly work your way down to finding x. If you look at number 12, I'm going to subtract 8, and then I have this negative 2, right? That's a negative dividing by 2. So then I'm going to multiply by negative 2. 12 multiplied by negative 2 is negative 24. And then I'm left with this parentheses. Then I'm going to add 24. And then I'm going to divide by 3. And this one you get an x equals 0, which is always fun, right? 0 equals 3 times what? Well, x has to be 0 if the output is 0. But again, I'm just doing one thing at a time to both sides of the equation just so I can get that little x all by itself. All right, now 13 and 14 are examples where there's more than one x, or there's x's on both sides of the equation, like on 14. Here, the first thing I'm going to do, how do I go from here to here? Well, I'm actually going to add like terms. X's with x's, numbers with numbers. So 2x and 1x make 3x's. 10 and 50 make 60. Well, now I'm just going to solve like normal. I'm going to subtract 60, and then I'm going to divide by 3. Over here, I'm going to go from here to here by the same thing. I'm going to combine like terms. This is a negative x, right? Subtracting x, so I'm going to add x to the other side. 3x plus x is 4x. And then I'm going to subtract 20. 60 minus 20 is 40. And I get this line here. And then I'm just going to divide by 4, because 4 times x is the same thing, or 4 times x, I want to divide by 4 to get rid of it. Okay, so the question is, when are we going to use this in geometry? And I want you to think about, we're going to get 13 and 14 stuff all the time. 13 could be, what if I told you we have 2 angles and the angles are complements? What if I told you we have 2 angles and they make a right angle together? Well, then you're like, oh, that makes sense. Angle 1 plus angle 2 has to be 90. So we're going to get this setup where we do one angle plus another angle equals 90, and then you're going to have to solve for x. Well, what do you end up when you go over here? Well, look at 14. What if I told you you had 2 angles that were vertical angles, and one angle was 3x plus 20, and the other angle was 60 minus x? What do you know about the 2 angles if they're vertical? They're congruent. So what do? You can set them equal to each other. So we're definitely going to have to take 2 things and set them equal. We're going to have to add them together and equal 90, or add them together equal 180 if they're a linear pair. So we'll see more and more examples of how this algebra will make its way into geometry questions. So 13 and 14 are probably the most realistic geometry questions, where the first 12 were kind of just reminding you of how algebra works.